Now we're going to look at scripting animation. And the easiest way to script animation corresponds to the easiest way to create animation interactively, namely auto key. So I'm going to start by creating a sphere here. Then I'll click on auto key, move the time slider to 100, move the sphere, and click auto key off. So that's the standard way for creating animation. I'll just delete that sphere. So this code corresponds to that. Animate on corresponds to clicking the auto key button, and at time corresponds to moving the time slider to a particular frame. So here we have at time 0, s.pos, that is the position of this sphere that we created up here, is 0, 0, 0. At time 100, corresponds to the time slider being up here, spos equals 0, 0, 50. So let's try this. And when I move the time slider, you can see that that sphere is moving up. It's at 50 on the z-axis at frame 100. And at frame 0, it's at 0 on the z-axis. So that's what this accomplishes. And both animate on and at time are called context prefixes because they basically create a context within which something is happening. Notice that you don't have to say animate off. Animate on creates a code block. This code block is executed and animate is automatically turned off at the end of the block. So let's look at a slightly more complicated example. I'll just delete this sphere. So once again, we're creating a sphere. We're turning animate on. This time we're saying for t in 0 to 100 by 5, do at time t, spos equals t, 0, 0. So we turn the animate on. Then we're creating a variable t, which will go from 0 to 100 by 5s. So it'll be 0, 5, 10, 15, 20, and so on. We move the time slider to those positions. So it's like moving the time slider first to 0, then to 5, then to 10, then to 15, then to 20, and so on. And we set the position of this sphere to 0 on y, 0 on z, but on x equal to the time. So the position, the x position, will be 5, 10, 15, 20, and so on. So let's evaluate that. And if you look at the position on the x-axis and the frame that it's at, they're always going to be exactly the same. And notice here, by the way, that keyframes have been created every 5 frames. When you're just creating linear motion like this, scripting isn't necessarily faster than doing it by hand. Although if you need all these keyframes, scripting is much easier. But in this case, you wouldn't actually need all these keyframes. You could just create one keyframe at the end here and get the same motion. But, for example, what if you want your sphere to move in a circle? Here's a script that shows how to do that. Once again, I'll delete this sphere. So this is based on a trigonometric formula, which says that if you imagine a circle on the main construction plane here, every point on this circle can be described in terms of an x and a y. Every point here has an x and a y coordinate, and if you knew every x and every y coordinate of each point on this, you could describe the whole circle. And there happens to be a formula for this. If you take the 360 degrees of the circle and you call whatever angle you happen to be at theta, so you'd start off at 0 degrees and go to 1 degree and 2 degree and so on, and that's theta, then the x point is the radius times the cosine of theta, and the y point is the radius times the sine of theta. So what I did here is I took 0 to 100, which is the time that I have to move in a full circle. I multiplied it by 3.6 in order to get 360. So that gives me my 360 degrees. Theta will go from 0 to 360, while t goes from 0 to 100. Then I just calculated x and y, and I set the position of the sphere to x, y, and I kept z at 0. So let's try evaluating this. And you can see that that sphere is moving in a circle. So that's animate on and at time. You can use them to create very simple animations, and with the right mathematics, you can create almost any kind of animation that you can imagine.